Hello grade 11s, and let's do the sine rule. Let's get straight into it, shall we? So what are we looking at here? Well, the sine rule, we're going to use our same triangle that we used yesterday/today, just to confirm that it works and then look at it. So let's go into it and describe what is the sine rule at all. So what it says is that if we take the sine of an angle and divide it by the opposite side, it's going to be the same no matter where. Or the inverse is true. So if you take a side and divide it by the sine of the opposite angle. Okay, so what do we mean? Let's start with A. A seems like a decent place to start. So if we take sine of 120 and divide it by the opposite side, 10,25, to one decimal place, what do you get? Yeah, I'm a little bit behind you. I've got, wait, sine 120. Brendan, where's your calculator? Divided by, I know, it's getting old now. Okay, I get S to D, sine 120 over 10,25, 0, well, I said one decimal place, so I'm actually going to go for 2 here. 0,08 something. So for the next one, let's get that right and say, let's go for the green, for B. So what's sine of 35 degrees divided by that opposite side, 6,79? To two decimal places, what do we get? Sine 35 divided by 6,79 equals, oh, surprise, surprise, not so much, 0,08, and the rest might be slightly different because of our rounding off. And finally, does the last one, and I'm going to leave it to you to write down the last kind of ratio, does it also equal 0,08? Hopefully it does. Okay, so we've got sine of 25 over 5, and let's go for it. Sine 25 divided by 5. This is a good practice of making sure. Out of interest, I wonder, did anyone get 0,087 as opposed to 0,084? Make sure that you've got your divide in the right place. Okay, 0,08. Cool, so the idea here is that take the sine of an angle divided by the opposite side and we'll always get the same thing. And the opposite is true. If we turn that around, then we're going to get the same. So I'm just going to do them here quickly and say, if we've got 10,25 over sine of 120, we're going to get the same as if we go 6,79 divided by sine 35, and finally the last one as well, 5 over sine 25. Each of those is going to be the same, but let's not belabor the point and rather get into some examples. So the sine rule states that in any triangle, let's write it here, in any triangle ABC, that if we take sine A over A, it's going to be the same as sine B over B, which is the same as sine C over C, and the opposite we said was true. A over sine A is the same as B over sine B equals C over sine C. So what we're saying here, sine angle over the opposite, yeah, in these nice colors. So cool, you've got that down, right? Okay, you've hopefully got that down. So where were we? We were here and saying, example 1. Give you a chance to sketch down the diagram. We're given two sides, and we're given this angle that's not included. Notice it's not side angle side. Yes, think back to What does that remind you of? Side angle side, side angle, right angle hypotenuse side, those things. And there was no angle side. Okay, so here we've got angle side. And I want you to please write down, just in brief, what's your strategy going to be to solve this triangle? In other words, to find out the value of A and the value of these two angles here. Okay, so you've written down something. We're interested to see what you've got. And let's start with trying to find out. Now I thought it would be useful to go, well, B65 and there's that opposite side. There's A and the opposite angle is over here. And finally, let's go yellowish and say, here's an angle and our opposite side is over there, just so we can keep track of things. So are we at some stage given an angle and an opposite side, and we're trying to find an angle and an opposite side? Yeah, here we go. Well, that side, yeah, C. The color is actually quite useful. So let's go for trying to find out C. So therefore, I'm going to start off by putting the unknown in the numerator. It's just going to be easier to work with. So sine C over 7, 8, that's equal to, well, let's find something where we've got both things, because this isn't going to help not knowing anything. And we've got sine of the angle divided by 11. Okay, cool. So we're going to times by 7, 8. Let's times that by 7, 8, 7.8, times that by 7.8, so that those cancel, and we've got sine C is equal to, what's it equal to? Sine 65 divided by 11, and then times that by 7, 8, 0.64 something or other, 0.64. Now notice, and you'll see this written down, this idea of ... Leave that in your calculator. Leave it in your calculator so that for the next step, when we're going, C is shift sine of that. I'm just going to go shift sine ons and get 39.99 degrees, which I can then round off to 40 degrees. So you don't have to retype that in, just shift sine of the answer. Right. So the slight pause is just, I thought let me do that bit in the calculator to make sure, to say, what were we saying? We said that sine C is 0.64, so for that we just went sine 65 divided by 11 times by 7.8. Alright, it's going to read left to right, so you could have written that as a fraction if you wanted to. And we get that 0.64 whatever. And then we want to do shift sine of that answer. And we'll get our 39.99, which is 40 degrees. So you see what I mean about leaving it in there as opposed to retyping this whole thing in. So you don't have to even show that shift sign, because we know that's what you're doing between those steps. So now we got our 40 and we saved it. Okay, so useful little one to do there. Let's get rid of the calculator and carry on. So we got C is 40 degrees. Let's put in the diagram. Now there are things we know. So now we need A. So that's great. We're just going to go, well, let's do it in green. We've got A over sine A equals, and doesn't matter which one of these we choose. I'm going to choose the reds because those were given, just in case we made a mistake with this 40 degrees. So let's go for, well, we've got the side on top. So we got 11. Remember this idea of keep this because then you just multiply. So keep the unknown in the numerator. 11 over sine 65. Wait a second, there are two things we don't know. A and angle A. But really we do know. How are we going to find out one of those two things? Okay, hopefully you've said angles in a triangle, 65, 40, 65 plus 40 gives me 105, so therefore this angle here must have been 75 degrees. So somewhere over here, I guess we, strictly speaking, should say A equals 75 degrees, sum of angles and triangle, but we kind of know that. Okay, so therefore we know that that's 75 degrees, so let's rub that out, replace it with 75 degrees without that funny angle. So times both sides by sine 75. So in other words, A equals all of this stuff, 11 over sine 65 times sine 75. Punch that into your calculator and we get 11,72. I'm not sure how many decimal places we want it. Okay, so there we go. Units, centimeters. I've just left everything as units. So we've solved our triangle. We found everything there is to find out about it. Cool, let's do one more example. And if we scroll down, example 2. Given two angles and one side. Again, I don't know, do you think it's a useful little bit to circle these, or you don't really need that? I don't know, be honest, I've only just thought about it now during the video, to be honest. Okay, so let's do it. I'm going to do it. I'm going to say there's an angle, there's its side. Here's an angle we don't know, but that side's across from there. And let's go yellowy, there's an angle and there's its kind of opposite side. Okay, so ideas. Let's leave this as one question. How are you going to solve this? Just jot down something of really just to show me that you've paused this and gone, yes, I can give this a go of trying to solve this, and then I'll go through it. Okay, so interested to see what you say. What jumps out to me is angles in a triangle, so we can find out what angle X is straight away and just go 180 minus 36,7 minus 110, 2 gives us 33,1. I remember a good question here about why C is 40 degrees, but why we didn't look at a second option of C like we did in class. Like, why isn't it 140 degrees? Maybe just think. Okay. So there we've got 33, so let's put 33,1. So we got that ready to work with if we need it. And now we can just run through going, well, sine of an angle over a side. And from here we can really run it home because we've got this Z. I always put my Z's with something through them like that, so they don't look like 2's, over sine 110, and that's going to be equal to, well, it doesn't really matter. Let's go for this one. I suppose we have to, because there's where we know two things. So we've got the angle at the bottom, sine 33,1 and 8,5. Multiply both sides by sine 110, and if you could hit the button, then Z equals, what does it equal? 8,5 divided by sine 33,1 times sine 110 equals 14,6 something or other. So I'm going to go to one decimal place, 14,6 units, centimeters. I don't know, if we've got no units, you don't even have to write units, but I'm going to put units there. Okay, what next? So we've got this bit here. Let's put a tick to say we know we've got it. Let's try and find y. Well, let's put the unknown on top. Y over sine 36,7 degrees. What is that equal to? Well, which one do we want to choose? I'm going to choose this one. There's more of a chance that I made a mistake finding out Z. So let's put it in here. In green, why not? So that's the angle was on the bottom. So sine 33,1 was on the bottom. What's on the top? 8,5. Love it. Multiply both sides by sine 36,7. So if we multiply this by sine 36,7, we multiply that side by sine 36,7. Here we get our next step equals, so we're trying to work out y. y equals 8.5 divided by sine 33,1. 8 divided by sine, I feel like we just did this one. You know, that sense of deja vu. Times sine 36,7 close bracket equals, well, what does it equal? What does it equal? Tell me. I'm getting excited. Come on. Give me my excitement. 8,7. Oh, something's gone wonky here. 8 divided by sine 31 times sine. Okay, let's check it out. Why could that one not be 8, what am I working out? Why? Let's just check this one out. I should have done this on the on-screen calculator. I said 8 instead of 8.5 divided by. See, concentrate. But have a bit of fun with it as well. Okay, so this isn't a what did I do wrong situation, because typing into the calculator is something boring to do wrong and not that interesting. Whereas that other one with the trig graphs is actually something vaguely interesting. 9.3 units if you really want, or just 9.3. That's that. Okay, so as long as you're not like me and you can actually punch into your calculator, then it's very weird saying calculator, and you're just going to go one side over sine of that angle is that side over sine of that angle, or the other way around. Hint, have your unknown on top, because notice here we just multiplied both sides by sine 110. Unknown on top, just multiplied by sine 36,7. Unknown on top, just multiplied by sine 75. Unknown on top, just multiplied by 7,8, rather than multiplying and getting into a mess. So if you can, unknown in the numerator makes our lives a whole lot easier. So just future practice here. 3 ABCD. Here they are. Thought this might be easier just to put it here at the end of the notes rather than share the whole textbook. Textbook coming as well. And the solutions for the questions that we did in class, ended up just working most of them out. And this one here, we'll catch that one when we meet in our synchronous lesson to see if you need a hand with question 5 from before. So I think that is it, and enjoy the rest of your day.